Hello everyone. In this video, I will discuss the partial fraction decomposition. This topic is important because when you get to Calculus 1, you will learn different techniques of integration. And when you integrate rational expressions, one of the techniques that you can apply is by partial fraction decomposition. So the main purpose for partial fraction decomposition is to write a rational expression as a sum of two or more simpler rational expressions. And there are 6 steps for partial fraction decomposition. The first step is, suppose you are given an expression n of x over d of x if the degree of the numerator n of x is greater than the degree of the denominator d of x. Then divide n of x by d of x to obtain a polynomial, the quotient, plus a remainder. And the remainder is denoted by n1 of x. And you only do this, step number 1, if the degree of the numerator n of x is greater than the degree of the denominator d of x. If the degree of n of x is not greater than the degree of d of x, then you can skip this step number 1. Now, step number 2, factor out the denominator d of x into the form px plus q raised to the power m and ax squared plus bx plus c raised to the power n, where ax squared plus bx plus c is irreducible. So that means that this quadratic factor or factors cannot be reduced or cannot be factored out. So what this means is that we are going to write d of x as a product of linear and quadratic factors, and the quadratic factors are irreducible. Step number 3. For each factor of the form px plus q raised to the power m, the partial fraction decomposition must include the following sum of m fractions. So if you have a factor of this form, then the partial fraction decomposition of this form will be written into sum of m fractions like this. And for each factor of the form ax squared plus bx plus c raised to the power n, the partial fraction decomposition must include the following sum of n fractions of this form. So if you have quadratic factors, then you will include this form in your partial fraction decomposition. Step number 5, write the form of the partial fraction decomposition. So write the combination of this and this one here depending on your factors of d of x. And then last step, solve for the variables a, b, or c in your partial fraction decomposition. Here is example 1. Write the partial fraction decomposition of the given rational expression x cubed minus 3x squared plus x plus 6 over x squared minus 4x plus 4. Now you notice in this rational expression, the degree of the numerator is 3 and the degree of the denominator is 2. And because the degree of the numerator is greater than the degree of the denominator, so first thing that we need to do is follow step number 1. We will use the long division to find the quotient and the remainder. Once we have a remainder, then we will apply partial fraction decomposition to the remainder. Now to divide x cubed minus 3x squared plus x plus 6 divided by x squared minus 4x plus 4, we can set it up like this by writing x cubed minus 3x squared plus x plus 6 divided by x squared minus 4x plus 4. Then we divide the leading term of our dividend by the leading term of our divisor. So x cubed divided by x squared will give us x. Then multiply x to every term in our divisor. So x times x squared is x cubed. X times negative 4x is negative 4x squared. X times 4 is positive 4x. Now subtract this result from the previous line. So x cubed minus x cubed is 0. Negative 3x squared minus negative 4x squared is positive x squared. x minus 4x is negative 3x, and then bring down the 6. And continue the process by dividing the leading term of this result with the leading term of the divisor. So x squared divided by x squared is 1, and multiply 1 to every term of our divisor. So 1 times x squared is x squared, 1 times negative 4x is negative 4x, 1 times 4 is positive 4, and subtract this result from the previous line. So x squared minus x squared is 0. Negative 3x minus negative 4x is positive x. And 6 minus 4 is 2. We only stop this process when the degree of the result is less than the degree of the divisor. In this case, the degree of our result is 1. The degree of our divisor is 2. So we stop the process and we call this remaining expression here as our remainder. So when we divide x cubed minus 3x squared plus x plus 6 divided by x squared minus 4x plus 4, the result is x plus 1 with a remainder of x plus 2. So after the long division process, we have a polynomial, the quotient x plus 1, and a remainder of x plus 2 over x squared minus 4x plus 4. Now we are going to proceed with step number 2, which is to find the factors of the denominator x squared minus 4x plus 4. And the partial fraction decomposition will only be applied to this remainder, to this rational expression x plus 2 over x squared minus 4x plus 4. And the factors of x squared minus 4x plus 4 is x minus 2 times x minus 2, and we can write this as x minus 2 squared. And because x minus 2 is linear, our partial fraction decomposition form is a over x minus 2 plus b over x minus 2 squared. And you notice that our exponent of the denominator starts from 1, and here on the second fraction the exponent is 2. That exponent is equal to the exponent here, the highest exponent of the denominator is 2. To solve for a and b, first is we need to have the same denominator, and because our denominator on the left side is x minus 2 squared, so our first fraction a over x minus 2, we're going to multiply this by x minus 2 over x minus 2, so that our denominator will be the same as the denominator on the left side, x minus 2 squared. And our second fraction, our denominator is already raised to the power 2. That's the same as the left side, so we don't need to do anything on the second fraction. Now that we have the same denominator, x minus 2 squared, we can disregard the denominator and just write the numerators. So on the left side, it will be x plus 2. On the right side, we have a times x minus 2 and plus b. To solve for b, we can let our x to be equal to 2, because if our x is equal to 2, this x minus 2 will be 0. So a times 0 is 0, so we can solve for b. So let x be equal to 2. Our left side, x plus 2, when you replace x with 2, that will give us 4 equals 0a plus b. So that means that our b is equal to 4. Now to solve for a, we can distribute a to the terms inside the parentheses. So a times x and then a times negative 2. And that will result here in this equation, x plus 2 is equal to ax minus 2a plus b. And we can just look at the coefficient of x. On the left side, the coefficient of x is 1. And the number associated with x on the right side, there's only one term with x here, which is a. So that means that our a is equal to 1. So then we can write this partial fraction decomposition by replacing a with 1 and b with 4. So our final answer is that x plus 2 over x minus 2 squared can be written as 1 over x minus 2 plus 4 over x minus 2 squared. Let's take a look at another example. Here is our example number 2. Write the partial fraction decomposition of the given rational expression x minus 4 divided by x minus 1 times x plus 3. Now you notice that in this rational expression, the degree of the numerator is 1 and the degree of the denominator is 2. So we can skip step number 1. We are also given here the factors of the denominator. So we can also skip step number 2. So we'll just proceed with step number 3, which is to write the form for the partial fraction decomposition of this rational expression. The partial fraction decomposition of x minus 4 over x minus 1 times x plus 3 can be written as a over x minus 1 and b over x plus 3. Now to solve for a and b, first is we need to have the same denominator. So the first fraction, a over x minus 1, we are going to multiply this fraction by x plus 3 over x plus 3. And then the second fraction, b over x plus 3, we are going to multiply this fraction by x minus 1 over x minus 1. And when we do this, we see that our denominators are the same. And because they are equal, we can disregard the denominator and we'll just write the numerators. So on the left side, we have x minus 4. Right side, we have a times x plus 3 plus b times x minus 1. And to solve for b, we can let our x to be equal to negative 3 because this part here will become 0 when x is negative 3. So when x is negative 3, the left side will be negative 3 minus 4 will give us negative 7. On the right side, x plus 3, when we replace x with negative 3, this becomes 0a. And then plus b, when we replace x with negative 3, so negative 3 minus 1 is negative 4. So therefore, our b is equal to negative 7 divided by negative 4. That will give us b equals 7 over 4. Now to solve for a, we can let our x be equal to positive 1. So when x is positive 1, this will become 0 here. This b times x minus 1 will be 0. So our left side, when x is 1, so 1 minus 4 is negative 3. And then a times x plus 3, when x is 1, this becomes a times 4. When x is 1, this becomes 0. So 0b. So that means that our a is equal to negative 3 over 4. So now that we have the value of b and a, we can go back to this partial fraction decomposition form and replace a and b. So therefore, our rational expression x minus 4 over x minus 1 times x plus 3 can be written as negative 3 over 4, this is our a, over x minus 1 plus 7 over 4, this is our b, 7 over 4, over x plus 3. Okay, that's all for today. Until next time, thank you for watching.